Hi, welcome back. It's been a while. If you're from Canada, November, December, very busy months, so I've been very busy with tire season, winter, all that fun stuff. But today we're going to talk about catalyst efficiency. Cat efficiency monitor, that's the big one everyone thinks about. Catalytic converters, most stolen item on a car. It's the big one people think about when they're thinking vehicle emissions. And it can be kind of confusing to think about how to diagnose a PO420 or PO430 when that comes in. So here's an easy way to simplify that next time you get one that comes in. This can also work with understanding basically how oxygen sensors and O2 sensors work. Basically what a converter is, it's just a bed of platinum, palladium, all those really expensive metals that work as a chemical catalyst. Catalyst being an item or chemical that accelerates a chemical reaction that is not part of the reaction. Catalytic converters do not get consumed as part of the reaction that they are participating in. It should last the life of the car. So if the converter dies, usually something takes it out. So that's something you should keep in mind when you see one of these codes. Now, you have two sensors, one on each side of the converter, to measure its efficiency. It can be two O2s, it can be an AF and an O2 sensor, or it can be two air fuel sensors. But what you have going in, there's always nitrogen in the air, 78% nitrogen in atmospheric air, and that goes into the engine. Then you got oxygen that's in our air at about 19-20%, and some other gases. We put fuel in, which is our hydrocarbon, and then that burns, and then we have our 5 gases that enter the converter: nitrogen, hydrocarbons, carbon monoxide, oxides of nitrogen, NOx, carbon dioxide, H2O, water, because that is part of combustion, and oxygen, because not all the oxygen gets used up in combustion. It goes through the converter heats up. If you're using a pyrometer and you measure before and after the converter, the back of the converter should be hotter by a pretty noticeable amount, usually about 100 degrees. Coming out of the back of the converter, you still have nitrogen, can't burn nitrogen, water, and carbon dioxide in a perfect world. But nothing's ever perfect, but that's kind of your ideal scenario. O2 sensors and AF sensors. The way I like to remember it, O2 sensors work on an oxygen bias. What that means is the more oxygen, or the less oxygen in the exhaust, the higher the voltage goes. If there is a rich condition in the exhaust, O2 sensor voltage will go up because it's looking at the amount of oxygen in the exhaust versus outside the exhaust. If you have a car that is freshly undercoated and they sprayed over the O2 sensors and cover up the little holes on the outside, I don't have an O2 sensor handy to show, but you can see them on any O2 sensors, little holes just like on the tip that compares atmospheric oxygen to exhaust oxygen. And that's how it predicts rich or lean conditions and produces a voltage. Air fuel sensors work the opposite way. Their voltage will go opposite of an O2 sensor. Oxygen sensors voltage up for rich, air fuel sensors voltage down for rich, on the brands I normally work with. Now, understanding that, how do we measure with a scan tool if a converter is actually working? By diagnosing these codes, we get that car in, put a scan tool on it. What do you do with it? What we're trying to check, and And what the computer is trying to check too is the converter's ability to store oxygen. So what you're going to do, if the car has the ability to do it, is a rich and lean active test, or do an output control of some kind. You want to force the vehicle to run about 10-15% richer and 10-15% leaner. And this is all done at idle with everything hot. Converters don't work when they're cold. When we pump a bunch of oxygen in by running the car lean, you can see a delay. The AF will respond immediately. And the O2 sensor, since it's behind, or if it's a AF sensor after the converter, doesn't matter. Whatever sensor is at the back of the converter is going to have a delay. Usually about 1 second if you're graphing it. And I would highly recommend graphing it because you're not going to see it just looking at the numbers. 1 second delay. You force it lean. You watch it store a bunch of oxygen. Your air sensor move to lean the second you commanded it, and you can see the O2 sensor slowly taper down, or eventually it'll just plummet when the converter finally fills with oxygen. And then you force it rich, and you watch the converter kind of burn off that oxygen. When the converter is dead and it's not working, you command it rich or lean. AF and O2 will be on top of each other on the graph. You command it rich, AF will move, and O2, your postcat, will move right away with it. There'll be no delay. It's all about the oxygen storage capacity. That's the big thing with converters. That's what the ECM's checking. It's all about making the ECM happy when you're trying to satisfy these monitors.